Hey guys, sorry for the delay. We will have this workshop right now. Our speaker is running just a little bit late. He'll be here in a couple of seconds. Until then, I'm very happy to see you in that you've come to this workshop after not happening last week due to technical difficulties. This is the final workshop in the Encode Summer Hackathon sponsored by the Solana Foundation. And yeah, after this workshop, you've got around 10 more days to submit a project. Next week or next Sunday on the 23rd of July, there's a submission deadline, which means you can submit your project roughly until point between now and that Sunday. As I've said before, but I'll repeat it again just for the sake of clarity, the submission deadline is in the Notion Hacker Pack, which I've shared before, but let me share it once again. Just a second, guys. Hey, Nikhil, welcome. I'm just, yeah, you can feel free to pair your slides or whatever, and I'll share the hacker pack with submission link in the comments. And yeah, whenever you're ready, feel free to start.
Sweet. Thank you. Sorry I'm a little late. Hey, everyone. Thanks for joining. Let me just organize my stuff real quick and share my presentation. My presentation is on another screen, so I'll be looking a little bit to the side. Let's see. Do you all see my screen?
Yes, we do. Feel free to start your workshop.
Okay, great. Thanks so much. So yeah, again, thanks for joining everyone. This is Wormhole workshop on how to build cross-chain dApps focused on cross-chain payments. So what I'm gonna do is I'm gonna give a quick overview of Wormhole so you understand the protocol, why it's a really valuable thing to build on for your dApps, and then dive into a specific use case, which is cross-chain payments or cross-chain deposits, and showing you how you can build that and different strategies for building that on Wormhole. Cool. So jumping right into it, what is Wormhole? So Wormhole is a cross-chain generic messaging protocol. But that's just the tagline. So what does that really mean? So what it means is it allows you to pass data from one blockchain to another blockchain in a standardized and secure way. So you can really easily take your app cross-chain. And so Wormhole supports 22 different blockchains. And one of the hard problems that Wormhole solves is that it supports both EVM and non-EVM chains. So Wormhole supports EVM, Solana, Cosmos, Algorand, Moonbeam, Near, and more. You know, all these ecosystems are connected through Wormhole. So why are we all here, right? We're here to build stuff and grow our projects. And so what can you build with Wormhole and how can it help you grow your project? So there are several reasons why Wormhole can be helpful to you as you build and grow your projects. So first, Wormhole allows you to expand your user base. With all the chains that Wormhole supports, you can tap into an incredibly significant number of crypto users. Basically all crypto users, almost. Second, once you have those users, you can greatly expand their reach. So now they get to stay on the chains that they're comfortable with, and they get to keep using the wallets and the UIs that they're familiar with. And they get to do all of this while staying in their own comfort zone. They can interact with any of these chains that Wormhole supports from applications that they're comfortable in. And finally, you and your team can focus on building where you have the most expertise. So building products in crypto is really difficult, as you are all well aware. Different chains use different languages. Different chains have different VMs. They all have different consensus mechanisms and finality guarantees. And then maybe most importantly of all, the security assumptions built into each chain's VMs and consensus mechanisms can be very different. And so if you're trying to build applications on multiple chains or build applications that go cross-chain, you have to think about all of these things. And so if you have a team with expertise in every single one of these ecosystems and in all of these areas, then that is really, really good. And you've actually just solved one of the biggest barriers to building in crypto. If you don't have a team with expertise in every single one of these areas, then you're like all the rest of us. And it's really challenging to go cross-chain. And so this is one of the biggest things that Wormhole unlocks for you, is it kind of abstracts away all of this. Wormhole abstracts away the security assumptions. It's built, we've built Wormhole accommodating for different security assumptions. We built Wormhole to be the same interfaces across all these different chains and VMs and consensus mechanisms and finality guarantees. And so you can continue building where you want to build, and you can seamlessly bring users to whatever ecosystem of choice you're building in. So I assume everyone here is really comfortable building in Solana, and you can just focus on building in Solana and bring users from any EVM chain or any other kind of chain to Solana, all while they are comfortable in their own UIs and applications. So we talked a lot about building. So what can you actually build with Wormhole? And there's no better inspiration than some of our favorite projects that are out there. So first, we should talk about the protocols that exist on top of the Wormhole generic message passing layer. So there's the token bridge, which is probably the most well-known use case of Wormhole. And then there's the NFT bridge. And as you might imagine, the token bridge lets you send tokens from one chain to another chain, and the NFT bridge lets you send NFTs from one chain to another chain. And so the way that these work is the token bridge mints a Wormhole wrapped version of the token or NFT on the destination chain. And what a lot of projects end up doing is they treat this Wormhole wrapped version as the canonical version of their chain, of their token on that chain. But of course, Wormhole is a generic messaging protocol, so you can do a lot more than just bridging tokens and bridging NFTs. So beyond the token and NFT bridging protocols, there are different products that are built on top of Wormhole. So some of our favorites are, really, really beautiful token bridge and NFT bridging UI is the carrier by the Automata team. There's Pith, which is a market data oracle, and it leverages Wormhole generic messaging to publish prices to different blockchains. There's Hashflow, which is a cross-chain native swap built on top of Wormhole generic messaging. And then there's Backpack, which probably all of you are familiar with, the Backpack project, which is a cross-chain wallet building XNFTs, and they're building on top of Wormhole as well. And then there's another project called Nexa, which is doing cross-chain token mints or X mints as they call it. So again, if you think about all these different projects and how they're using Wormhole, they're using these strengths of Wormhole that we talked about earlier to expand their user base, expand the reach of their users, and then focus on building where they have expertise, or helping other projects like you focus on building where where you have expertise and bringing users to where they are. Excuse me. So let's see the next slide. So yeah, we're gonna go into how a little more technical, how Wormhole works and how you can integrate with Wormhole. But I don't know if there are any questions that people have, or are we saving all questions until the end?
Yes, I don't think that people have questions at the moment, but yeah, feel free to leave questions in the chat and Nikhil will get to them at the end.
Cool, thanks. So with all this high-level stuff aside, we are at a hackathon. We want to know, how does Wormhole work and how exactly do we integrate with Wormhole? So we'll go over some diagrams and then we will dive into some code. And so you can pull code up right now for a couple of different GitHub repositories. And we're going to navigate through them. This is from a bit of an old presentation, so we have a borrow lend example in there as well. If you're curious to look into that, you can look into that, but we'll probably focus this presentation on the cross-chain deposits example and the Wormhole repository. Actually, there is another repository. I'm not sure which screen you see. I'm going to stop sharing and reshare really quickly and just reshare my full screen. Cool. So for Solana specifically, there's this Wormhole scaffolding repo that has basically an anchor SDK for interacting with the Wormhole Solana smart contracts. The Solana smart contracts were written using an old framework, and we've written this anchor SDK to make that process of integrating with Wormhole and Solana a lot easier. And we'll go through this anchor SDK later. As well, we'll dive into how you actually integrate with it and the instructions and everything. But just wanted to call that out. That is in the Wormhole scaffolding repository under Wormhole Foundation, and it's under Solana modules Wormhole Anchor SDK. But going back to the presentation for now, let's move on to some diagrams of how Wormhole works. So an overview of how Wormhole works technically, we have contracts deployed on every network that we support, EVM, Solana, etc. And these core bridge contracts take care of three key things. The first one is publishing messages, which then get bridged to another chain. The second one is verifying messages that are coming from another chain. And then the third one is executing governance actions. So that's what this diagram over here shows. This diagram shows, for example, ETH, Solana, and other chains. There's a core contract that's been deployed on each of these chains. Integrators building dApps or off-chain applications can call into these Wormhole core contracts to publish messages, and then these messages will pass through the Wormhole core layer and get sent to other chains. And for example, if a message is sent from Ethereum to Solana, the core contract on Solana will then verify that message that's coming from Ethereum. So the next question is what's in this core layer? How do messages actually move around from one chain to another chain? They can publish messages and verify messages, but they actually have to get there. And there has to be a process by which they're verified as valid. So that's what's in the core layer, and that's where the Wormhole guardians come in. So Wormhole is a multi-sig bridge. There are 19 Wormhole guardians, And what they do is they run full nodes for every single chain that Wormhole supports to observe messages that are emitted on those chains, and then they wait for the messages to reach a certain finality or consistency level. So for example, for ETH, they'll wait for finality, which is around 15 minutes. And then once a Wormhole message that they've observed has reached finality, they will sign that message. And when 13 out of 19 of the guardians have signed a message, we call that a VAA, which stands for Verified Action Approval. And then this VAA exists in the Guardian database, and each Guardian has RPC endpoints that you can query against to get your VAA, and then you can submit this VAA to the Wormhole contract on the target chain, which does that process that we described in the previous slide of verifying, the message. It verifies the signatures, the Guardian signatures on that message, and then allows you to perform whatever action you need to perform. So again, just going over the steps, there are 19 Guardians. They run full nodes to observe messages on all the chains that Wormhole is connected to. Once they observe those messages, they wait for the message to reach a given consistency level depending on the chain. And then they sign the message once the message has reached finality or effectively finality. They will sign the message, and 13 out of 19 signatures is the threshold by which a verified action is produced. And then you submit the VAA to the contract on the destination chain. So this slide shows you the entire life cycle of the Wormhole message flow. So how a message gets from a source chain to a destination chain in 8 steps. So the way this works is on the source chain, the first step is the integrating contract or off-chain program will call the Wormhole contract. The Wormhole contract with a certain message to emit, the Wormhole contract will emit that message as a Wormhole message, as an event, or however else you can emit messages on various other VMs. And the Guardians are listening to the events emitted by the Wormhole contracts. The Guardians will observe those events. They will then, once the events reach finality, they will then sign the event, sign the message, and they will produce a VAA. And then there is some relayer of the message. A relayer can be an untrusted process. Anyone can pick up the VAA and deliver it to the target contract on the destination chain. So basically, the relayer will get the VAA from the Guardian. It will submit it, will deliver it to the destination chain. The contract on the destination chain will then call the Wormhole contract to verify the VAA. So it'll verify that this message is valid and signed by the Guardians. And then the Wormhole contract will return true to the integrating contract, and the integrating contract can then take whatever action it needs to based off of the message. So how do you as the developer plug into this whole thing? So there are 2 things. First, you write the program or the integrating contract. So the integrating contract or program, the program, if it's, it can just be JavaScript if you're doing it through a UI and calling RPC nodes, or it can be a contract if that's what you need to build. But you write that on the source chain, and then you write the contract on the destination chain that integrates with the Wormhole contract on the destination chain. So those 2 things are what you need to... Attention. Those 2 things are what you need to do to integrate with Wormhole. And then we are working on deprecating this step with a feature called automatic relaying. But for some, and automatic relaying is live on EVM, and I think the next place where it will be live is Solana. But in some cases, you will need to, in some cases where automatic relaying is not yet live, you need to write a customized relayer, or you need to write a relayer that will pick up the VAA and deliver it to the destination chain contract. And it's a pretty simple piece of off-chain infrastructure that we have a good framework for as well. Okay. Cool. So let's get into some code. So with the overview of Wormhole aside, we can kind of look through the Wormhole repositories, understand if you want to integrate with Wormhole, what are the things that you need to look at. So I want to make sure you can navigate effectively through the repo. You know all of the plugin points to integrate with Wormhole, and then I want to show you how to actually integrate. For example, how could you actually build cross-chain payments or cross-chain deposits using Wormhole? So what's in the Wormhole repository? The Wormhole repository just contains a whole bunch of, it contains the contracts and the Guardian implementation effectively, and white papers. So if you wanted to look at the Solana contracts, which you can do if you want, I don't necessarily recommend, because again, they were written using an old framework and they were not written using Anchor. If you want to look at the Solana contracts though, because you're curious about the implementation, that's in the Solana directory. And yeah, it was written using Solitaire. So that's in the Solana directory, and you can look through the implementation of the contracts here. There's the core bridge and the token bridge contracts in here. So this folder has the core bridge implementation, and then the modules folder has the implementation for the token bridge and the NFT bridge contracts. So you can look at the actual implementations for Solana here. Where I would recommend looking at for Solana is go to the Wormhole scaffolding, Solana modules, Wormhole Anchor SDK repository. And here we have a really nice wrapper around the contracts that were written with Solitaire that's been written in Anchor. So you have a wrapper for integrating with the Wormhole core bridge contract in here. And so if you look here, there's a nice wrapper for publishing a Wormhole message. And this is how you would integrate if you wanted to build something directly on the core bridge. And then there's a wrapper for integrating with the token bridge. So if you wanted to bridge tokens back and forth, you would integrate with these methods here. You would integrate with, if you want to transfer tokens from Solana to another chain, you would call this transfer with payload. Transfer native with payload is for the native asset, and then there's also transfer wrapped with payload. So you would integrate with one of these to transfer tokens out of Solana, and then to verify transfers from other chains, you would call these functions: complete transfer wrapped and complete transfer native. Cool. So let me just think. So here, this presentation was written with EVM contracts, but yeah, for the Solana contracts, these are basically the plugin points, is via the Wormhole Anchor SDK. And then one thing to note is if you want to build directly on top of depends on what exactly you want to build, and I'd be curious to hear what you guys want to build with Wormhole, and I can help sort of give more targeted guidance on whether you should integrate directly with the core bridge or whether you should integrate with the token bridge. But generally, if you want to do something with bridging tokens, you should integrate with the token bridge. And you won't need to worry about like calling any Wormhole core bridge functions like post message. The token bridge contract calls into the core bridge contract. So the token bridge is built on top of the core bridge. When you are bridging tokens, there are kind of two ways that you can build tokens, and this gets into what I call level 2 composability. So the simple way of building, so what this means is like you can build like a protocol that's built on top of the token bridge. So if you just use the token bridge, you can send tokens from directly to a recipient. But what you might want to do is, especially for the cross-chain deposits use case, is you might want to not just bridge to a recipient and then have the recipient take subsequent action. You want to bridge tokens to a contract, and then the contract will interpret sort of an additional message that you include in your bridging payload, and then the contract will be able to automatically take a subsequent action, like swapping a token or sending a token, like depositing a token into a pool or something like that. And so the way that you would do that with the token bridge is you would call this when in these functions transfer with payload, you would populate the payload here, and your recipient address would be a contract, and the payload would be a arbitrary payload that you would encode, that your receiving contract would understand, and then could decode, deserialize into some kind of action or instruction to perform after receiving those tokens. So that's how you can move beyond just simple token bridging and get into sort of more complex use cases where you can automatically take follow-up actions after a token is received, and automate a lot more of the process. The other thing actually I should show is, for example, I'm not sure where your core protocol is going to live. If your core protocol lives on Solana and you want to bridge tokens or messages from other chains into Solana, you don't want to call these transfer functions on Solana. You would use these complete transfer functions on Solana. So your contract would use these complete transfer functions to do the CPI into the token bridge contract. So that's what you could use the Anchor SDK for. But to actually produce the message on the source chain, you don't need to, for example, if you're not familiar with how EVM works, you don't need to write an EVM contract or a different VM contract to produce those Wormhole messages. We have an SDK that lets you just produce them via JavaScript. So you can like call directly. You can, use our SDK, or you could even like serialize the transaction yourself and call it using like ethers or a different library. But again, that might be a little too in-depth if you're not super familiar with how EVM works or how other VMs work. Our SDK kind of abstracts all that away and gives methods and provides methods for calling like initiate transfer or publish message on different kinds of VMs. So so the SDK is a published npm package. I think it's Wormhole SDK is the npm package, but basically if you go into SDK, JS, this is where the package exists. And yeah, on npm, it's under Certus1 Wormhole SDK. So that's the npm package that you would pull in. You can look through the code base for all the different kinds of methods that we expose. For example, if you wanted to call token bridge methods, you can use these methods here. So for example, transfer from ETH. You would call this method from JavaScript, and it would wrap sort of a lot of the ETH specific stuff for you. Or transfer from Terra. No one's using Terra anymore. We have transfer from all the different chains that Wormhole supports, basically. So transfer from Solana, transfer from Algorand, et cetera, et cetera, et cetera. And going through the code can be a little bit arduous. And so we do also have the Wormhole book at book.wormhole.com. We're working on improving this documentation, but here you can see examples of how you can you call into the token bridge from JavaScript, and how you can perform token transfers through JavaScript. So this has some documentation around the SDK. So specifically it's here, Wormhole TypeScript SDK. So doing token transfers, and then bridging tokens, and getting the VAAs and submitting the VAAs, and then completing the transfers, and all these things. Cool. So let's get into how would one build cross-chain deposits really quickly, given all, I know this has been a lot of information, but how could you use Wormhole to build cross-chain deposits? We have an example repo. It's in EVM, so you might not be as familiar, but the principles are really the same. And I'll go over the principles right now. So to do a cross-chain deposit, or to do a cross-chain payment, the simplest use case is to just bridge a token from one chain to another chain, where the Wormhole wrapped representation of the token will be minted, and then give that Wormhole wrapped token to the recipient. That's the simplest use case of a cross-chain payment or a cross-chain deposit. But you will likely want to, and that might work for some of your use cases, but you may also want to have more complicated use cases where you're able to go from, let's say, any source chain and token on that source chain to any destination chain and token on that destination chain. So you might want to go from the example given here is, ApeCoin on Ethereum, which is kind of a random coin on Ethereum, to USDC on Polygon, or for your use case, it would be USDC on Solana. And so what's needed here is that integration with the token bridge, where you have a sending program on Ethereum that triggers a Wormhole transfer on the source chain for whatever token the user wants to bridge. And then you write a receiving contract on Solana that uses the Anchor SDK. So if we go back here, you could use the Anchor SDK to call this and call this complete transfer native with payload. And you would this would do a CPI into the token bridge on Solana, and the token bridge would then validate the VAA, and then after the VAA has been verified, your contract could perform a swap of the token, of the Wormhole wrap tokens it receives to the target token that you want to convert to. So whether that is USDC on Solana or a different token, maybe native Solana, you would be able to perform that swap from your contract. So there are, I guess, different strategies for doing these swaps. So ignore the pictures here because, again, these are EVM. But basically, actually, I'll just talk through on this slide. This is going to be a little confusing. So there are different strategies for doing these swaps, depending on what exactly you're trying to build or the product that you're trying to offer. So one strategy for doing the swap is you just you bridge the token from the source chain, and you get the Wormhole wrap token. And then let's say you want to convert everything to USDC. Then you will just find a market on the destination chain. So you would find a market on Solana, let's say, where you have liquidity for the Wormhole wrap token and USDC pair, and then you perform the swap there. But obviously not every token is going to have great liquidity because users might want to transfer arbitrary tokens. And so the challenge here becomes it's really a trade-off between like it's a trade-off of where you can find the best liquidity for the swaps that you want to perform for these cross-chain swaps. So for example, another strategy, if there's better liquidity, could be, let's say, and I'm just going to change this to Solana so it's a little clearer. Let's say you wanted to do this case where you wanted to go from ApeCoin on Ethereum to USDC on Solana, but Wormhole wrapped ApeCoin on Solana doesn't have great liquidity in a USDC pair. Another strategy you could follow is you could convert the ApeCoin on Ethereum to USDC, and that probably is going to have good liquidity because almost every token on ETH has good liquidity with USDC, or usually much better liquidity with USDC. And then you take the USDC and you Wormhole wrap that into Wormhole wrapped USDC on Solana. And then the Wormhole wrapped USDC with canonical USDC is going to have much better liquidity. Is likely going to have much better liquidity. There are also strategies where you can integrate with cross-chain dexes. So for example, I showed you Hashflow up here. Hashflow is a great cross-chain dex that supports native to native swaps. So if you wanted to, if there was good liquidity on Hashflow, for example, from USDC on Ethereum to canonical USDC on Solana, then you could use Hashflow for that portion of your swap, instead of having to deal with a Wormhole wrapped representation of USDC. And Hashflow is built on top of Wormhole generic messaging. So these are just various strategies that you can do to perform cross-chain swaps and cross-chain payments, cross-chain deposits, whatever exactly your use case is, using the Wormhole token bridge. Cool.
I think we have a question from Armando, if you don't mind. What about gas? So how is gas handled in these transactions?
Oh yeah. So how gas is handled is, again, if you want to do these kinds of cross-chain swaps, it's again a trade-off between, I guess, how much gas you want to trade off between liquidity, gas, and time it takes to bridge. So those are really the three factors to consider: is slippage, gas, and time that it takes to bridge. So for example, you might have great liquidity for a token on ETH, but it might cost a lot more gas to do a swap on ETH than it will to do a swap on Solana. So maybe your trade-off calculation is that it's better to not do any swap on ETH and do the wormhole wrapping of the asset, and just bridge the asset and get a wormhole wrapped asset and do the swap on Solana, even if the slippage on Solana is a little bit worse than the slippage on ETH. So there's not a catch-all solution, but that's the framework that you want to use to think. That's the framework that you want to use to think about how to do cross-chain swaps. Is it's a trade-off between gas, slippage, and time it takes to bridge. And the reason I mentioned time it takes to bridge is because if time is a really important part of your product, if speed is really important to your product, then I guess you can't really there are strategies to get around it if you're bridging from Ethereum. But for example, time it takes to bridge is based off of finality on the source chain. So if you're bridging from Ethereum, it'll take 15 minutes. If you're bridging from Solana, it'll be almost instant. So if you're bridging from Ethereum and you really want to speed it up, you could also, there are strategies where, depending on how much risk you're willing to take, where you can front the payment on Solana and do the swap on Solana before the Ethereum reaches finality, before the Ethereum transfer reaches finality. So yeah, those are the parameters that you want to think through for doing this cross-chain swaps.
Cool. Thank you. And Armando actually has a follow-up question, if you don't mind. Do you have auto calculation, or do we have to do it ourselves?
Auto calculation of gas?
I assume so. Yes.
Auto calculation for which portion? Like
Gas/slippage, says Armando.
Oh no, there's no auto. Again, Wormhole, the protocol itself doesn't, do swaps. There's no like swap protocol built into Wormhole itself, and so there's no auto calculation that of slippage or gas that like we provide right now.
Cool. Yeah. Thank you very much. Feel free to proceed with the workshop. We'll have 10 more minutes left, so I think we can slowly go towards the end. If you have any final thoughts. Yeah. Cool.
I mean, yeah, that was all I had.
Yeah. Okay. Amazing. Thank you very much. If you guys have any further questions, feel free to pop them in the chat. Until then, I'll ask one more question myself, and it's the same question I've been asking all our speakers: is what kind of use cases would you like to see with implementing Wormhole and Solana? What kind of projects would you like to see from this hackathon and from the people hacking with Wormhole?
Yeah, sure. I think there are a lot of really exciting things to build with Wormhole and Solana. Obviously, one really exciting use case is doing cross-chain swaps or cross-chain deposits. Like I said before, I think there's been no really great sort of any token to any token liquidity layer that's been built. And I think that would be a really, really exciting thing for us to see. I think another exciting kind of protocol or another kind of protocol we think is exciting is cross-chain borrow-lend. And so building a borrow-lend protocol that allows users to deposit tokens cross-chain and perform withdrawals cross-chain and like deposit tokens from one chain and borrow tokens from another chain. I think that's something that hasn't been really built yet either that we would be really excited to see. And the presentation has a link to, if you're interested in building something like that, we also have an example repository under the Wormhole Foundation GitHub organization. That's example cross-chain borrow lend. And this has a great README. It goes through different strategies that you can take to like build this kind of a protocol. And then I can keep going, but one other exciting, oh sure, I will paste the link for the cross-chain borrow lend. Here you go. Another pretty exciting thing, another thing we think is pretty exciting is anything that just generally anything that uses the generic message passing layer. So a lot of these are built directly on top of the token bridge, which we think is exciting, but we really think the generic message passing layer is also quite powerful, and you can do things beyond just bridging tokens. So things around, governance via the generic message passing layer, we think is really exciting. Things with decentralized ID using the generic message passing layer is another pretty exciting use case. Yeah, that's what I would say.
Cool. Thank you very much. I don't think there are any further questions at this point, so I think we're out of time anyways. Thank you, Nikhil, once again for the amazing workshop. I think that everybody very much enjoyed it as much as I did. And yeah, otherwise, guys, thank you very much for coming. This was the final workshop for this hackathon. And like I said, now we have around 10 more days until the submission deadline on the 23rd of July. The submission link is in the hacker pack, which I've pasted in the chat. If you have any kinds of questions, feel free to reach out to me or to anybody at the Encode team, and we'll help you out in any way we can. So yeah, my message to you is, guys, is get building, get creating, get coding, and can't wait to see what kind of projects you come up with in the next couple of weeks. Thank you very much, and thank you to Nikhil once again, and see you guys the next time.
Thanks so much. All right.